Alright, so let's talk about our graphs of sine and cosine for a little bit here. So, this is the picture of y equals the sine of x, where x is in radians. Okay? So, what can you tell me about some observations of that graph? Domain. What is the domain of the sine of x? What values of x can I put into sine and get out an answer? Remember, it continues in this pattern all the way for whatever angle. And for whatever angle. All real numbers. The domain here of the sine of x is all real numbers. Okay? Range. Range is y values that we would get out of it then. What is the range of the sine? -1 to 1. Okay. Would I put that in interval notation or inequality notation? Interval. Okay. So how would I put it in interval notation? Brackets or parentheses to start? How about a bracket? Because it can be equal to -1, right? At 3 pi over 2. Can it be equal to +1? Yep, so we put it like that. Or in inequality notation. Okay? Now, if you didn't see that that was the range, you could look at what is the maximum value. What's the high point of the sine function? Well, the high point would be up here, and that would be at +1. So that would be a +1. That would be the high. The right end, remember, when we talk in range, we're going low to high. Okay? The low value would be right down here, and that would be at -1. Okay, so there's my range again, low and high. Okay, which means the middle of my function is at 0. Y equals 0 is the middle of my function. Okay. Love it. Amplitude. Does anybody remember what the word amplitude means? So it's like the height of the wave, right? Okay. So that's the distance. Okay. The amplitude is the distance from the middle to the high, or the distance from the middle to the low. Okay. That's the amplitude. The distance from the middle up or the middle down. So in this particular case, the amplitude is also 1. Because we start in at the middle, we go up to 1, start in at the middle, down to 1. That gives us a distance of 1. Okay? Where the next two are, where does this curve start? Sine curves start where? Start in the middle, right? Okay, so the sine curve starts in the middle. So this would be the start. So it would start at x equals 0, right? Okay. And then it goes, sine curves go up, come back down, and then end in the middle. So a sine curve would start at 0 it would end at 2 pi, which means the period is the horizontal distance that it takes to make one complete wave. Okay? That means the period then would be 2 pi. How long it would take to make one complete wave on our graph. Okay? What I would like you to do now is I would like you to explore answering those exact same questions, but now with cosine. Domain, range, high, low, middle, amplitude, start, end, period. Okay? Answer all of those exact same questions, this time now with cosine. Domain of cosine. All real numbers. The domain of all sine and all cosine functions will always be all real numbers. Okay? Because there's no values that we can't put in and get out an answer. Okay? It's the only 2 of the 6 trig functions where that holds. It's the only 2 where the domain is all real numbers. Okay? In tangent, cotangent, secant, and cosecant, there are restrictions. Okay? And we'll dive into that later on. Range of cosine. Range of cosine. -1 to 1. Same as sine, right? Bless you. Maximum value of cosine. So the high. 1. Minimum value of cosine. The low. Middle of cosine. Amplitude of cosine. Okay. Cosine starts at 1, then it goes down, all the way down to -1 when it reaches a value at pi, then goes back up and ends at 2 pi back up at the top. Okay? Where does cosine start? It starts up, right? So the start for cosine would be here. And the end then would be there. So in terms of horizontally, what x value does it start at? 0. What x value does it end at? 2 pi, which means the period is 2 pi. Horizontal distance to make one complete wave. Okay. So, what we are going to be talking about for the remainder of this week, today, tomorrow, Friday, and I think the first or second part of the 4 mod day, what we're going to be talking about here now are transformations. Okay? So, transformations of these functions. So, here are your general forms of the functions. Here is your cosine function. Here is your sine function. A times B, or A cosine or sine of B times the quantity x minus C, then plus D. And we're going to figure out what A means, what B means, what C means, and what D means. All of those different values are going to have different kinds of transformations on your regular cosine and sine functions. Some of them will stretch them horizontally or shrink them horizontally, stretch them vertically, shrink them vertically, shift them horizontally, shift them vertically. Okay? So all transformations will be to show what was done to the first lap wave. So the first lap wave is that very first one. On cosine, the first lap wave goes from 0 to 2 pi. And on sine, again, from 0 to 2 pi. So we're talking that first lap wave on cosine here is is that one, and then on sine is this one. Okay, that's that first lap wave. So, like for instance, next week, Wednesday, I believe we are going to have a test on graphing these things. Okay? And it's going to be a 6-question test. Graph this, graph this, graph this. Answer these couple of questions to go along with them. Okay? We want a picture of the first lap of that one, wherever that first lap gets shifted to. Okay? All right. On all of them, the domain will still be all real numbers. Okay? So, the first one is A. So let's dive right into A. A stands for the amplitude. Okay? So, A is the amplitude. And remember that the amplitude is the distance from the middle of your curve to the top and from the middle to the bottom. It's the height of the wave. That's all that A does, is it's the distance. Okay? For right now. In a couple of minutes, A will do one more thing. Okay? So, let's graph y equals 2 sine of x. We know already that the domain is all real numbers because it's a sine function. Okay? If it was a cosine function, it would still be all real numbers. Now, there are two different schools of graphing. Okay? I will do the next 2 examples in the 2 different schools of graphing. Okay? The first school of graphing is, this is a sine function, and so my sine function is going to be graphed where I start in the middle, I go up, I come back down, I dip below, and I end in the middle. So the first school is you put the graph on the paper. Okay? And from that, then, you would fill in all of your different informations. Okay? For instance, sine has a middle in this case of 0. Because my amplitude is 2, that means that I go all the way up to 2, and I go all the way down to 2. Oops, excuse me. To negative 2. Which means my high would be 2, and my low would be negative 2. That also tells me the range. The range is negative 2 to positive 2. The first lap of sine starts at 0, ends at 2 pi, because it has a period of 2 pi. So this would be 0, this would be 2 pi, halfway would be pi, halfway would be pi over 2, halfway 3 pi over 2. These directions will be on all of the graphs. You're graphing them without a calculator. You're labeling the x-axis, that's in green here, and you're labeling the y-axis, that's in blue. Every graph needs to be labeled, both x and y. And you're going to label it with, on the horizontal, you're going to label it with the 5 key points. End, or beginning, end, and the 3 middles. The middle of the beginning and the end, and then the middle of those 2 halves. Okay? Vertically, you're going to have the 3 points, low, middle, and high. Okay? That is the first school of thinking. Put the graph on first, and then go from there. Okay? On this particular one, and I will get rid of this goofy box. Okay. On this particular one, actually, let's tap the brakes on this one for a second. Let's go to this one, because it's got a positive A value. We'll come right back to that one, just so you know. We'll come right back to it. Okay? So on this particular one, because I want to show you the second school of thought. Okay? So this one has an amplitude of 1/2, which means my high is going to be 1/2. My low is going to be negative 1/2, because my middle didn't change. Stayed at 0. I start at 0, I end at 2 pi, because my period is 2 pi. All real numbers there, and those there. Okay? I know I went kind of fast on that, but do you all understand how I got all those numbers? Okay? Until for another 10 minutes or so, yes, the period will always be 2 pi. Okay? here's the second school of graphing. Okay? 0, I need to get all the way out to 2 pi. Half of that is pi. Half of that is pi over 2. Half of that is 3 pi over 2. The second school of graphing is you set your horizontal distance first, then you set your vertical distance, okay? And then you say to yourself, okay, cosine starts up. So I need to start there. Cosine then goes to the middle, then it goes low, then it comes back to the middle, and cosine ends up top. A little too high. Still a little too high. Okay? And then you fill it in. Either way, you're still getting the exact same end product. It's kind of like when you're multiplying fractions. You can either multiply the two fractions first and then simplify, or you can simplify your fractions and then multiply. Okay? It doesn't really matter which way you go. All right? What I'd like you to do now is I would like you to now graph this function. Domain is all real numbers. Do we agree with that? That's an always case. Okay. Amplitude is 3, not negative 3. 3. The amplitude is always positive because it's a distance. Okay. My middle is 0, high of 3, low of negative 3, which means my range goes from negative 3 to positive 3. I start at 0, end at 2 pi, which means my period is 2 pi. Okay? Now, normally, cosine would start on top, right? Right? So the cosine of 0 should be 1. Which it is. If I look at my unit circle, the cosine of 0 is 1. Right? Times negative 3 is negative 3. So this one is actually going to start down low and then go up. With me? All right. Now, what I'd like you to do is I'd like you to get out those, oops, we'll skip that one for right now. So, what's up?
Where you decide we start on the y-axis?
Depends on what you're, it really depends on what you are. If you're on a cosine, you're going to start up. Okay?
And since it was negative, we started low.
So we started low then, yep. Yep, because that's going to bring it back down. If we're sine, we start in the middle, no matter what. Yep. Okay? So the amplitude A is not only the distance, It's not only the distance there, but it also, if it's negative, it will flip the graph. Okay? It will flip the graph if it is negative. So this one, let me get back to it now, maybe not. That one, so sine now, instead of going up and coming back down, it's going to start and it's going to go down and come back up. So this graph would come down. Oops, I missed. A bad hump. And go like that. Here it would be negative 3/2. Here it would be positive 3/2. Here it would be 0. Okay. Alright, what I'd like you to do now is, on your calculators, I'd like you to open up a brand new document. And in said document, I would like you to open up a graph, and I want your window to be x's from 0 to 2 pi, y's from negative 2 to positive 2. Okay? So we start with a new, so you double tap the on button, new document, add a graph, and it's going to look like that. Then we're going to go into menu, window and zoom, window settings, and here now we're going to go 0, 2 pi, and use the pi key. Okay, the pi key is located on the pi key, way down here at the bottom. Okay, you get pi there. Let's go by pi over 2's as our scale. Hey now. And then negative 2 to positive 2, and we'll go by 1's there. It should. Yep, yours does. Yours just rounded. It rounded it to a decimal. Mine just has it as exact. Okay. So now, my first function that I'm going to put in is going to be sine of x. Okay. So to plug that in, sine is located. Actually, all of the trig functions are located in the trig key. Okay. So I'm going to put sine. Oops. Missed it. Sine of x. And when you do that, you should get the first wave of the sine curve. Okay. If you don't, your calculator is in degrees and not in radians. Okay? The second function that I'd like you to put in is sine of 1/2 x. So you're going to tab and you're going to go the sine of 1/2, oops, back to me, x. Now, what do you notice? Blue is my parent function. What's wrong with red? So what's wrong with it? Is it a complete wave? No. How much of the wave do we have? Half of it. Okay? We only have half of that wave, which means that we can't see the other half. So how far would we have to go out to see the whole wave? We'd have to go all the way out to 4 pi, right? So the period of this one was 2 pi. The period of this one was 4 pi. Okay. Using the same window, okay, and you can clear out both of those now, but using the same window, what I'd like you to do is I'd like you to take a little bit of time here, and I'd like you to explore on the calculator these 5 functions over here and try and figure out what their periods are. Okay? We'll get to Ric Flair in a minute. So, what you should have found from your exploration is that the period of the cosine of 2x is pi. So you should have seen in your window, you should have seen 2 complete cosine waves in there. Cosine of 1/3 of x, that one would be a little more tricky. You probably saw some of the cosine curve, okay, but you didn't see all of it. You only saw 1/3 of it, which means that the period would be 6 pi. If you expand your window out to 6 pi, you would see 1 complete cosine curve to go along with it, or cosine wave, excuse me. Sine of 3x, you should have seen 3 of them in your window, which means that the period here is 2 pi over 3. Sine of 4x, you should have seen 4 of them in your window, which means that the period is pi over 2. Remember, the period is the amount of distance horizontally it takes to make a complete wave. And cosine of 1/5 x, that one would have been a 10 pi length period. Okay? Now, based off of that, and those are all true, can anybody tell me how we can relatively quickly decide what the period of a function of a trig function is. Based off of all those. Can anybody tell me what the period of a trig function is? Go for it.
Is it 2 pi divided by
2 pi divided by b?
Yeah.
Now, do you know who this guy is? That's Ric Flair. He's the greatest of all time. Okay? Okay? There's a saying out there called 2 claps and a Ric Flair. Woo! Because that's it. Exactly. 2 pi divided by b. So the period, the amount of horizontal distance that you have to go, is going to be 2 pi divided by, and we threw in the absolute value of b, because sometimes b can be negative. And we'll talk about that more tomorrow. Okay? All right? So this, the period, that remember, that's going to give us our start and our end. Okay? Or from our start, that's going to tell us how far out we have to go. Okay? So, let's graph one. Okay? So we want to sketch now the sine of 2x. Okay? So again, there are two different philosophies on how to do these. Okay? Same as there was before when we were doing amplitude. You can start with the sketch of the curve because you know it's a sine curve. Since you know that it's a sine curve, you know that we're going to start in the middle, we're going to go up, come back down, and we're going to end in the middle. So you throw the curve on there. I know because there is a 1 there that my maximum is 1, my minimum is -1, right? And my period here is 2 pi divided by 2. And I get that second, that downstairs 2 from that number. Well, that 2 pi over 2 is just pi. So it's going to start at 0, and it's going to end at pi. Which means halfway would be pi over 2. Halfway of the left half would be pi over 4. Halfway of the right half, 3 pi over 4. Again, it doesn't matter which school of thought you go on. Okay? We'll do the next one on the other graphing school of thought. Okay? Good to go on that one. Cosine of 1/3 of x. Okay? Now, we're going to go the other school of thought. Again, since there's a 1 here, that means that we are going to go up 1, down 1, which makes 0 be our middle. Figure out my period. The period of this function is going to be 2 pi divided by 1/3. Uh-oh, dividing fractions. What do? Flip and multiply. So this is going to be 2 pi, pi times 3 over 1, which is 6 pi, right? So that's going to be all the way out here is 6 pi. Halfway, 3 pi. Halfway, 3 pi over 2. other halfway, add these two together, divide by 2. Okay? Always adding together and dividing by 2. You're taking the average. Okay? 3 times. Once to get the middle one, then the average of the left half, then the average of the right half. Add them together, divide by 2. Okay? Cosine, here now. Now we go to the cosine. Cosine starts high, comes to the middle, goes to the bottom, back to the middle, ends at the top. And then you smooth curve that in. If it were sine, it'd be middle, high, middle, low, middle. Okay? Cosine, high, middle, low, middle, high. Okay? Questions on that stuff? It's good times. We'll be dealing, so we dealt with A's and B's today. Tomorrow we'll deal with C's and maybe some D's. Okay? Friday we'll put it all together and maybe start some curve fitting. And then, yeah.